So I've had lots of questions about the 9-2 practice, numbers 19 through 22. So I'm going to do these in this video for you guys so you guys can see how to do the problems. Okay, so first of all, what we're going to do is we're going to find the area of the sector, and we're going to subtract from it the area of the triangle. And that's going to equal the area of the segment. So let's talk about what we're going to use for these. So area of a sector is pi r squared theta over 360. The area of a triangle is 1/2 base times height. Okay, so let's go ahead and plug our numbers in here then. So our area of our sector, this is our area of our sector right here. That's our sector. That's what we're going to find first, all of that. So that's going to be pi times 1 squared times 90, that's what that angle was, over 360. And then we're going to subtract from that this triangle right here, the area of this triangle. So I'm going to go ahead and pull that triangle out right here. And it says it's a 90 degree. And if that's 1 centimeter up there, then this has to be 1 centimeter here because all radii in a triangle are the same. So that means that this would be 1 and this would be 1. So this is my height and this is my base. So what I'm going to do then is I'm going to subtract from that 1/2 1 times 1. So when I do the multiplication of pi times 1 squared times 90 divided by 360, I get 0.79 here. And when I take 1/2 of 1, because 1 times 1 is 1, that's going to be 0.5. So when I subtract 0.5 from 0.79, I get 0.29. And my unit is centimeters, so the answer is going to be centimeters squared. So that's how we do number 19. All right, sorry, going too fast, 20. So this one is similar. Again, remember, this is what we're going to do. We're going to find the area of this sector. That's pi r squared theta over 360. And we're going to subtract from it the area of our triangle again, this right here. So that's going to be minus 1/2 base times height, right? That's how we're going to find the area of our segment, which is the gray part, okay? So once again, let's populate this formula with what we have. So we have pi, we have 20 squared, and then we have theta, which is 90. Going to divide all that by 360. Then what we're subtracting from that is, again, let's talk about our little triangle here. So this is 90, right? So that means, again, we've got 20 up there, so our other radius here is also 20. So this would be 20, and this would be 20. So this is our height, and this is our base. Remember, height is always a perpendicular from the base, so this is our base. So that means we're going to do 1/2 of 20 times 20, right? So when we do this problem, when we get our angle measure, or our area of our sector here, this is going to be 314.16. And then when we do 20 times 20, that's 400. Half of 400 is 200. So we're going to subtract 200 from that. So our answer for this one is going to be 114.16. And this time again, it's going to be inches squared. All right, our next problem. This one's a little different, but we're going to do the same thing again. So we're going to do our pi r squared theta over 360, subtracting from it 1/2 base times height. So once again, we're finding the area of all of this. So to do that, we're going to do pi times 11 squared times 60 over 360. And then we're going to subtract from that. Now, this time our triangle is going to be a little more complicated. So let's pull this one out, okay? So here again, we got 11 and 11 here, right? Because those are two radii. So we're going to go 11 and 11 here. I'm going to bisect that angle up here. So this was 60, the whole thing. So that means this part right here would be 30. And this part right here would be 30. We have two right angles down here. That's what we created by bisecting the angle at a perpendicular bisector. Okay, so that means if this angle up here is 30, this one down here has to be 60, so this is now a 30, 60, 90 triangle, right? So we know that our hypotenuse is equal to 2 times the short leg. Well, our short leg is going to be opposite our 30-degree angle, so our short leg is going to be down here. So we're going to go 11 divided by 2, right? Because that's going to be 2 times the short leg. So our short leg is going to be 5.5. So if this is 5.5 here, then that means this over here has to be 5.5 too. So that means our base is going to be the two of those added together, which would be 11, right? That's our base. So the base of our triangle, base equals 11, right? Now, let's talk about what our height would be. So our height is going to be the long leg of this triangle, right? So long leg is equal to the short leg times the square root of 3, right? So our short leg is 5.5, so this is going to be our height now that we're talking about, right? So that would be our h. H is equal to 5.5 times the square root of 3. So that's our height. So our height is equal to 5.5 times the square root of 3. All right, so now we're going to put this in here for our formula like we've been doing. So it's going to be 1/2. Our base was 11. Our height was 5.5 times the square root of 3. So now what we need to do is find each of these and do our formulas, and then we'll plug in the values for them. So when I did this, I got 63.36 here. And then when I multiplied 1/2 times 11 times 5.5 times the square root of 3, I got 0.39. So my ultimate answer here was 10.97. And on the key it said 10.96, but when I did this I got 10.97. And again, this is going to be kilometers squared. Okay? All right, last problem is the one with 120 degrees. So here again, we're going to do pi r squared theta over 360 minus 1/2 base times height. So we're going to do pi times 4 squared times 120 over 360. Sorry, can't write today, apparently. Okay, and now I'm going to pull out this triangle again. We got this one this time, right? So here again, if this is 4 here, then this has to be 4 here, right? So both of these are going to be 4. This time we had a 120-degree angle, right? So each of these would be 60 and 60, because we bisected the angle. We got a right angle down here. If that's 60 up there, then that means this one down here has to be 30 degrees. And this one down here would have to be 30 degrees. So once again, we're going to use what we know about a 30, 60, 90 triangle. We've got our hypotenuse is equal to 4. So 4 is equal to 2 times our short leg, which this time would be our height, right? Because it's opposite the 30-degree angle. So that would mean our height is equal to 2, right? Then we know that our long leg down here, across right there, is going to be long leg is equal to the short leg, which was 2, times the square root of 3, right? So that means this is 2 square root of 3 here, and this is 2 square root of 3 here. So to get the whole base, though, remember, we got to add those two together. Well, 2 plus 2 is 4. So our base, our height was, if you remember over here, 2. And our base is going to be 4 square root of 3. So now we're going to plug those into our formula over here, like we've been doing. So that's going to be 1/2. Our base was 4 square root of 3. And then our height was 2, right? So we're going to multiply all those together and figure out what they are. Okay, so when I did this, I got 16.76 here minus 6.93 here. So my answer is 9.83. And again, we're talking about miles this time squared. So hopefully seeing me do those 4 examples or those 4 problems will help you guys.